All right. Good morning, good evening, everyone. Welcome back again. Great. So let's continue with yesterday's discussion. I can quickly recap what we covered yesterday in few minutes, and then we'll get started with the other few topics in continuation to that technical discussion what we started yesterday. So we discussed about, I briefed about myself, my overall experience, and what are the major activities and major areas of expertise what I have it in this Oracle world. I'll be the one who will be delivering this entire course. And then we discussed about a course curriculum. Hope you have gone through this particular blog link which contains all the course topics what will be covered in this course. And feel free to go over it one more time. And then if any topic is missed or anything need to be added, feel free to ping me on my WhatsApp number. I'll take that feedback. And then we started with the understanding of the course durations, course timing, and the fee structure, and what is upcoming batch schedule and other things we discussed here. So these are the links which talks about the course curriculum, course content, and other stuff. So again, feel free to go over these two links. I'll ping it in the chat here. But in the overview manner. So yesterday and today are the two demo sessions what we conducting and will be conducting using these demo links, which will be publicly available, and we all anyone can join here for this demo. And actual class is going to start by next week, 3rd of April, and this is going to be a weekdays, so it's not a weekend. So, but that will be only 2 days. Weekday batch timing is going to be 8:30 a.m. IST to 11:30 a.m. 3 hours on Thursday and 3 hours on Friday. 2 days in a week, and we should be able to complete in 7 weekdays. And
Malik, 7 weekdays means 3 weeks and 3.5 weeks, right?
7 weekdays. So it'll be maybe you can
Or
take it 7 weekends. It'll be 7 into 2. It'll be 14 days or 16 days. 7 weekdays. Maybe it's not like only 1 day, 2 day. Like 1 weekend, 2 days we're going to cover. So let's say weekdays, 7 weekdays, 2 days in a week. So for totally 14 days. It may go beyond that.
Okay.
So it's a paid training of 15,000 or 185 US dollar. Will be covering 19C version over a Zoom session. And we understood about the minimum requirement for this particular course, the basics of Linux, SQL, and Windows, and the hardware requirement and the database knowledge is must. Once we meet this condition, then we can register for this course. We'll be getting started on this next week, 3rd April onwards. Right, so that's a course duration, timing, fee structure, what we discussed yesterday, and followed by the Google Drive link and the WhatsApp group. Hope like few guys or few students who are registered yesterday and day for today, they are not yet got the access, and who joined a few days back, they already got access and they're part of WhatsApp group. Probably please stand by until today's class. I'm going to add all of you guys who are registered into this WhatsApp group. We'll be using a WhatsApp group for primary communication or any questions, queries, or any discussion. We'll use that WhatsApp group as a primary communication mode. And again, coming to that Google Drive, so I'll be granting that access to all those registered students shortly after this class. And once you get the Google Drive access, you can start exploring more on watching the previous batch recordings and watching the current batch recordings. Every day, whatever I take the class or demonstrate, everything will be recorded and uploaded on this link for that's a current batch recordings. And you'll be getting these previous batch recordings where you can watch those recordings well in advance so that make these live sessions interactive. Another links are your link one is course materials, PPTs and workbook and lab exercise will be available. Link two where you can get all the softwares, tools, entry questions, automation script, and many more things in this. Right. So as I told, few guys have already got access and they started watching the recordings, but who joined yesterday or day for yesterday, last 2 days or 3 days. So they will be getting access on today after the today session, and then you can get started with that. All right. And then we started with some technical discussion yesterday about architecture networking, and then we'll continue further from that point what we stopped yesterday. So any questions so far
Yeah,
on
Malik,
this?
I have a quick question.
Yep.
What's going to be the total duration of this course? Like, how many weeks is it going to take for us to conclude the course?
7 weekends, 7 weeks, and 14 classes together. Thursday, Friday, 2 days in a week, and 7 weekends. So probably
Oh,
14
so
days.
this course, yeah, yeah. So this course is just going to be only Thursdays and Fridays?
Yes.
Okay,
Three,
I was thinking it's going to be like 2 hours every week, like Monday to Friday, like we did the
no, it
previous.
will be Thursday, Friday, 3 hours on Thursday and 3 hours on Friday. And it will take seven, you can say weekdays or weekends. So it'll be 14 days.
Okay, good. So that's Wednesdays and Thursday Eastern time, right?
Right. In Eastern
Yeah.
time, it's going to be 1 day behind. So that will be 10 or it may be 11 p.m., I believe. 11 p.m. to 2 a.m.
Okay. Thanks.
Call it. So let's continue for the further discussion. If no questions, I'll take a pause for a minute if anyone has any questions so far. If not, then we'll get started with some and further continuation to the technical discussion what we started yesterday. All right. I'll take it as a no, no questions. Then we'll get started. So RAC versus standalone, we talked yesterday. So most of the common entry questions, what is RAC versus standalone, and then why RAC, and what are the advantages of RAC? And we talked about here in this slide. So standalone will be having only one instance and one host where no high availability, no load balancing, no failover. So whatever the users connected to this instance one, if the instance crash, these users will be failover to this instance two or the instance three. So there's no failover concept in case of standalone, and the load will be evenly balanced across all the rack cluster nodes and the failover and high availability. High availability meaning if the node 1 is not available, you have a node 2 and node 3 for the end user connection, the new connections. That is for high availability. So all these features are mainly part of your rack. So standalone, you won't get it. So very first thing is what we talked, high availability. So high availability, how we can achieve? So this multiple rack cluster nodes will help in end user connection. In case any node down, we have other other nodes to serve the client connection. So that's the meaning of high availability. High availability meaning one node is down. That doesn't mean that entire database is down. You have other cluster nodes where the other cluster node will handle those end user connections. So for high availability, again, scan will come into picture. So scan will provide you client side connection high availability and also server side connection load balancing. Again, how there will be a lot of things to talk about scan, but the moment somebody asks what is HA and how HA works in RAC cluster, you should answer these many points, bullet points, so that will be clear to them. So multiple RAC nodes will be in the cluster. If one node or one server is down, you have other cluster nodes which will serve that end user connection, the new connections. That's your HA. And that will be handled by your scan. The scan will serve this end user high availability, the connection side, client side connection high availability, or end user connection high availability. And also scan will serve the server side load balancing. And then again, we talked about scan default. I'm talking about default. Default are three IPs, and you can have only one IP, that's fine, two IP, that's fine, three IP, or even 4, 5, 6. You can have whatever IP you want, but default will be three IPs. So give me 1 minute, guys, here. All right, sorry for that. Okay. So this is about your high availability, one of the major feature in RAC. And the other feature what we talked, other advantage what we talked, load balancing. So again, couple of questions around that. Who is responsible for load balancing? Again, scan is responsible for load balancing on the server side. And what is scan? We have a definition and then how it works, functionality. We'll take a look in our actual classes. The scan architecture and connection high availability and load balancing. That's a fundamental architecture of scan. We'll take a look in deeper analysis. How scan is able to perform the load balancing? I have a 4 node rack cluster. How scan is intelligent? How scan is able to perform this load balancing? On what basis? How scan is aware of how much load is on my cluster nodes? So all will be internal architecture of scan, and we'll go in deep and understand that scan load balancing. How scan is able to identify what is the current load on the cluster nodes, servers, how many users are connected, what's the load on those server, how is able to calculate that. And how many IPs scan has it? Default is 3. Can I have some custom IPs? 3, 4, 5, 6, or 1? Yes, it's customizable. Is a scan VIP or the physical IP? So scan is a VIP. So some people will say scan IP or the scan VIP. Scan IP or scan VIP. So people will call it as any one of that, scan IP or scan VIP, but scan is always a VIP. Great. Other feature what we talked about rack is the failover. Why we need a VIPs? So for failover, VIPs comes into picture. Very, very important. Virtual IPs. Because of the VIPs, we will able to perform this failover. Without VIP, we will not be able to do a failover. What all the transactions are supported for failover? A user connected to node 1, he is doing select query, he is doing DML query, he is doing insert query, he is doing update query. Is all those DML queries are supported for failover, or is only select query supported for failover? Or what about DML, DDL, TCL, select query are all supported for failover? So we'll go in deep understand what are supported in failover. So those are your major understanding or the difference between standalone versus rack. And with that major feature, again, there will be multiple questions in the interview. You can get all these questions. Right, so that is one simple major difference between the standalone and RAC, what we understood. And we started with the explanation or understanding of the networking or the IP addresses. So here are the IP addresses what we explored. Where is that? Right here. So we started with exploring yesterday about networking and IP address requirement. So I have this node 1, node 2, 2-node RAC cluster. I need a public IP, right? And then I need a private IP, right here, private IP. And then I need a VIP, 2 VIPs for each node. And I need the scan IPs. So one of the common questions in the interview, in order to set up 2-node rack, how many IPs are needed? So with this, whatever the IP requirement I put down here, you should be able to answer. 3 IPs for node 1, public, private, VIP. 3 IPs for node 2, public, private, VIP. 3 plus 3, 6 IPs are must or mandatory. On top of that, scan IPs. Based upon default consideration, default setting, 3 IPs for scan. And it's going to end up with 3 plus 3 plus 3, 9 IPs totally we need to set up 2-node rack. So that's the default I'm talking about. Scan, you can have whatever customization you want it, 1 IP, 2 IP, 3 IP. Based upon that, the total IPs will get changed. But these are must. Yeah, go ahead.
Yeah. So scan IP belongs to which node? Node 1 or node 2?
Scan is a VIP. VIP will not be specific to node. It can be run on any of the cluster node. I showed you yesterday, scan 1 will be running on node 1, scan 2 and 3 will be running on node 2. And once the cluster node goes down, and they will move to any of the available nodes. Your
Okay.
VIP and scan IPs are not the physical IP. Those are the VIPs. So they can run on any of the cluster node.
Okay. So like we already have public, private, and VIP, right? On top of that, also we require these three IP extra, which are scan IP.
Right. We have set up Y physical IP, Y VIP, Y scan IP. Again, these are again your interview questions, scan IP or scan VIP. So as of your prior to 10G, only physical IP. As of your, or you can say your prior to 10G, there are only physical IP. No VIP concept, no scan IP concept. Give me 1 minute, guys. Right, in prior to 10G, there was only physical IPs, no VIP, no scan IP. And in 10G, VIP introduced. Oracle has introduced your VIP. So then we end up with, in 10G onwards, 2 IPs, physical IP, and then VIPs for each node. And again, we already understood why VIP to support that a failover. And in 11G, scan IP or scan VIP introduced. And we already have this physical IP and VIP. Then we have this scan IP or scan VIP. So that's the architecture evolved. How these IPs are came into picture. Prior to 10G, it's only physical IP, and then in 10G, VIP introduced to support that failover, and we end up with this physical IP and VIP. And in 11G, they end up with the scan IPs. And why they came up with the scan IP on top of VIP? Scan has its own advantages, load balancing, and client side high availability, and other things. So all will be your advantages and why we end up with these many IPs in rack. So those are must.
So, Malik, then one question come. Prior to 10G, there wasn't any kind of load balancing or high availability in
No,
that.
no.
Okay. So then at that time, why we used RAC? We do not have load balancing, we do not have high availability. Then why did we use RAC prior to
That's a rack
10G?
evaluation. So in prior to 10G, it's not a rack, it's a parallel servers. We used to call it as a parallel servers.
Okay.
All right. So we'll talk more in depth, but that's your high level understanding, high level the answers for any of these questions in the interview around this networking. Right. And then again, you might be getting a questions, why three IPs or multiple IPs for the scan? So it's not a default, like it's not mandatory. Default is three IPs. On top of that, you can have any number of IPs for scan, but why? That is for the client side high availability. We'll discuss or explore more in our regular classes. And then you might be getting couple of questions around this. Why physical IP? Physical IP meaning the IP assigned to an interface. Like you have these interfaces in your server, you're going to assign IP for that. That's your physical IP. What is VIP? VIP does not have any interface, so it'd be just assigned or running on any of the server. And why scan IP? Again, scan has its own load balancing and high availability. Again, many people will call it as a scan IP or scan VIP. Actually, scan is a VIP. And the private IP. Private IP is nothing but is also a physical IP, right? But it will be in a different network. Is a scan a VIP or the physical IP? The scan is a VIP, not a physical IP. Again, remember what is physical IP? Physical IP is assigned to interface. Your private IP also a physical IP that will be in a different network. Both your physical IP and private IP are one and same, meaning both are having the interfaces attached to interface. Why it is attached to interface? Because we need a strong network. Physical IP and private IP should be in a strong network and there has to be interface associated to that. And again, further questions you may come across why private IP is in a different network. So private IP is also a physical IP, but it's a different network than your physical IP. And then why it is needed in the different network? Because why can't in the same network of physical IP? Already physical IP we have it. So we have this physical IP here, 192.168 1.101, 192.168 1.102, the public IP. So you call again there will be some confusion. The public IP, some people will call it as a public IP, some people will call it as a physical IP. Both are one and same, referring to the same. Right. Either you can call it as a public IP or physical IP, referring to this a public IP of a node or a server or a host. Similarly, your a private IP also a public IP or the physical IP, which will be in a different network than this 1 series and 2 series. Why private IP is in different network? Why can't private IP be in the same network of the physical IP or the public IP? Because a private IP will be more used in my cluster. Private IP is private IP is more used in cluster for network heartbeat check, disk heartbeat check. Again, there might be a couple of questions. What is network heartbeat? That's a node-to-node communication. And then disk heartbeat check. That is your node meaning the rack servers. Whatever the node 1, node 2, that's your rack servers or the host, Linux server. Node to disks. Disk nothing but your voting disk. Node to disk communication or voting disk communication is your disk heartbeat. So network heartbeat will be done using your private network, or the disk heartbeat will be done using your private network. And cache fusion. What is cache fusion? We'll talk in detail about regular classes. The block database buffer cache transfer between one instance to another instance in a RAC nodes, and cluster node communication. So all this heavy network activity will happen in private network. Because of this private network heavily used, so I don't want to interfere with this physical or the public IP. So physical IP and public IP is only for the end user connection. All the end user traffic will go under this physical IP or public IP. Other than that, whatever the internal communication will happen through this public network. So this private network. Because of that, a public network and private network both are very, very important. Public network is for end user client connection. All the traffic will follow through this public network or the public IP or the physical IP, and whatever the internal communication will follow through this a private IP. Because of these two network are heavily used, and we're going to attach those physical IP and the private IP to an interface to get the strong network. Other than that, whatever the VIP and scan IP will not be assigning to any interface. Those are virtual IPs, will be floating in any of the cluster node. All right. Then a physical IP, VIP, scan IPs are meant for client connection or the client transaction, and all will be in a same network. So physical IP, or you can call it as a public IPs. Again, at this point, you might be getting confused. What are these IPs? Why these many IPs? I'm repeatedly telling and using them. These all come into picture once you understand the architecture thorough. But these are all expected questions in the interview. You call it as a physical IP or public IP or the VIP or scan IP are meant for the client connections or the client transaction to serve that transaction. So all will be in the same network. If I go back here, a public IP or the physical IP, it's a one dot series. And your VIP, again, one dot series. And your scan IP or the scan IP, again, one dot series. All should be in the same network, except your private IP, which will be in a different network. That is for internal communication. All right, so that is too much for the networking and too early for at this stage. So once you start with this course and you'll understand more on this networking and architecture part. All right. Then what we discussed yesterday, we discussed about the installation part, prior to a 10G and post 10G. This is what we discussed. So prior to a 10G, we used to do this node 1, node 2. But we used to download this cluster software and install on node 1. Once we install on node 1, automatically it used to copy to second node. And download your ASM software and install on node 1. And once I install on node 1, it automatically copy to second node. And install your database software on node 1 and automatically it used to copy to your second node. That's the prior to 10G. And 10G post onwards, Oracle has combined this cluster software and ASM software and renamed as a grid software. So now we are just downloading that grid software and installing it on node 1, use your own grid, and automatically it used to copy to second node. And download that database software and install it on node 1, automatically it used to copy to second node. That's a high level simple installation what you do. And this installation people will call it with a different name. You call it as a grid infrastructure software, or you can call it as a ASM software, or you can call it as a clusterware software, or you can call it as a GI home, ASM home, clusterware home. It's all referring to one and same single software. In my system here, I already showed. I'll do one more time. Node 1, Node 2. So this is my grid software, LS. So whatever the software I installed here, it's a grid software under this U01 app 19C grid. I installed it on node 1. Automatically that installation is copied to your second node, and second node also the same software got installed. Right, it's all many people will call with any of these names: clusterware home or ASM home or grid home or ASM software, clusterware software or grid software, all are referring to one and same. And for the RAC home, many people will call it as a Oracle software or database software or Oracle home or database home or RAC home and RAC Oracle home. These all are referring to one and same. That's your database software or database home. So I installed here U01 app Oracle product 19C DB home 1. So in this location here, I installed my database software. Same thing on second node. I install it on node 1. Automatically that installation is copied to my second node. If I do ls or ls, so these are my database software. So you can call it with any of these names based upon your convenient. But in reality, it's one and same. This whatever the name you call, it's referring to single software. Whatever you mention any of these name, referring to single same software. Right, what we talked yesterday, grid or ASM or clusterware installation. Download your 19C grid, ASM or clusterware software on node 1. Unzip that 19C grid software into the directory and run grid setup. And then it will ask you enter that physical IP, private IP, scan IP, all those details. And then it's going to copy that GI or ASM software from node 1 to node 2 and then start your ASM instances and set up your cluster. So that's your simple 3 steps how we can do a 2-node rack setup. And then end result will be something like this: node 1 and node 2, your grid software and your ASM will be running here. Right, so that's what I told here. This is my grid home, what I installed. LS, and again on node 2, LS, and then I'll be having my plus ASM2 here on node 2 and plus ASM1 on node 1. That's my result expected once I set up my cluster or grid. And now Oracle home or database home or RAC home installation. Download 19C Oracle or database software on node 1. Unzip that 19C Oracle or database software into your Oracle home, which home you want to install, and then run the run installer. So if I go to this home on node 1, this is my database software which I installed, and this is my database software which is copied to second node as part of this run installer. And then it's gonna show the moment you unzip the database software and run this run installer on node 1, it's gonna select all the RAC cluster node because we already set up a RAC cluster here. It's gonna select all the RAC cluster nodes, and then it's gonna set up that Oracle home on node 1 and copy that Oracle home to other nodes, whatever the RAC cluster node you selected. And your end result will be node 1, and you'll be having this grid home, ASM1 will be running, grid home, ASM2 will be running, and then you have this Oracle home and Oracle home, no database yet. And then third step, Once your grid home is ready, Oracle home is ready, and now we'll go ahead with the database creation. So database creation will connect to node 1 and we'll go into that Oracle home bin. Inside that we have this DBCA, so database configuration assistant, and then it will ask you all the details: name, SID, SGA, PGA, data file location, FRA, and then your database will be ready. Right, so that is your overall installation process, what we discussed yesterday, and then brief discussion today as well. And now once your database is ready, and you can see something like this: ps-ef grep smon. I have this plus ASM1, which is part of my cluster, and prod CDB is one of the database instance what we created. And second node plus ASM2, which is on node 2, and prod CDB instance 2, it's the second instance running on node 2. Both are these instance 1 and instance 2 are referring to the shared storage. Your database will be in a shared storage. So you'll be having your database instance 1, database instance 2 running on this 2-node RAC cluster, and both are referring to the same database. Prod CDB is your database. Prod CDB instance 1 is running on node 1. Prod CDB instance 2 running on node 2. All right. I'll take a pause here for a minute if any questions so far.
Malik, is there any difference between 19C rack installation and 12C rack installation?
There is some difference.
Okay. So if I have successfully done the installation for 12C, the same process I cannot follow here.
Little change.
Little change.
Yeah. So we have, believe, okay, here. So this is 11G, 12C, 19C. The grid installation. We used to have run installer, now become grid setup. And then your Oracle home installation, 11G, 12C, 19C. So there is a small change, but again, the process remains same. All right. So now let's explore more on that. So as part of my RAC architecture, what I showed yesterday, that RAC internals, we understood the installation process, and then we understood the IPs, what are the IPs are required. Again, that's a high level. We don't know. We have to go in depth on those IPs and installation process. And we understood yesterday about the cluster resource. So just to show one more time that cluster resource plus ASM1 CRSCTL stat resource -t. So will be a lot of cluster resource. So I'll just go with one single -t-init. So we have this cluster resource, Ora plus ASM cluster interconnect, HAIP, CRF, CRSD cluster ready service, CSSD cluster synchronization service daemon, and CSSD monitor, CTSSD cluster time synchronization service daemon, diskmon, EVMD event monitor daemon, GIPCD grid inter-process communication daemon, GPNPD grid plug and play daemon, MDNSD broadcast message daemon. So all this has its own unique definition and purpose and the task. We'll explore more on that. All this cluster resource will be running as a OS level daemons, OS level process. You can run this ps-ef grep d.bin. So we'll be having all those CRSD, CTSSD, OCSSD, CSS agent, GIPCD, all will be having this OS level process IDs, and it has its own function and task. It will explain more in our actual class why cluster resource and cluster daemons and what's a task and what's a purpose. So there'll be hundreds of resources we to understand, and then they're gonna basically help you to form a cluster communication. Node 1 to node 2 communication, node 1 to disk communication. If any of these cluster resources are not running or shut down, So your entire cluster will go down. Right, that's your total architecture. In order to explain or understand rack architecture, you need to do understand this all the cluster resource, a cluster IP addresses, and your installation process. That's gonna conclude your architecture by thorough understanding of these three concepts. Once this is done at cluster level, then your rack database. So rack database, the very first thing is your database architecture. Somebody asked yesterday, a database architecture, is there any changes? So your database architecture remains same. Your instance plus database combining together, it will form your database server. So only thing is your database is a unique, a single, but you will be having multiple instances. So in simple definition, your instance is nothing but a memory plus background process. So we have this instance one, it has its own memory and background process. We have this instance two, it has its own memory and background process. And in my case here, I have this a prod CDB instance on node 1. So it has its own memory and background process. I have this prod CDB instance too, and it has its own memory and background process. That's your instance basic definition. So instance 1 has its own memory and background process. In instance 2 has its own memory and background process. In case here, prod CDB instance 1 and prod CDB instance 2. Again, we know that if I go inside of memory, part of HG and PGA. And if I go with the background process, so background process will be having mandatory background process and non-mandatory background process. Again, for mandatory background process, few examples are SMON, PMON, your DB writer, your log writer, your checkpointer, are all of your mandatory background process. Again, we have non-mandatory, your archiver, recoverer, and etc. Non-mandatory. So whatever the basic fundamental architecture that remains same here for rack, but it will be having multiple instances. That's the only difference. Otherwise, your architecture will remain same. And the other part of your database architecture is database. Database is nothing but your data files. So in case of my single instance or single database, standalone database, will be having multiple files like SP file or P file, control files, data files, system, sysocs, undo, temp, users, redo logs, redo 1, 2, 3, archive logs, password file, alert log, and diag logs. The same concept is applicable to your RAC database, but few of the files are shared and few of the files are non-shared. In case of RAC database, shared versus non-shared files. Meaning whatever these files you can see for the single instance or the standalone database, same files applicable for your RAC database as well. But some of them will be shared and some of them are non-shared. Again, one of your interview questions, which are files are shared and which are files are non-shared. So your SP file is shared, whereas your P file is non-shared. And your control file is shared. And your data files, few of the data files, system, sysocs, temp, and users are shared. And few of the data files are non-shared, like your undo. And your password file may be shared or may not be shared. You can have a local individual password file with the same password, or altogether you can keep it inside your ASM disk group. And your redo log is non-shared. You will be having your redo log, and you'll be having your node 1 specific redo log and node 2 specific redo log and node 3 specific redo log. So if it's a two node rack, you'll be having a one set of redo log for node 1, and you'll be having one set of redo log for node 2, which are non-shared. And on top of this redo log, we'll be having arclog, which are non-shared. So node 1 is going to generate its own arclog, node 2 is going to generate its own arclog. And your alert log, non-shared. My instance 1 will be having its own alert log, my instance 2 will be having its own alert log. All the diagnostic logs, my trace, TRM, incidence file, code dump files, all are instance specific. Node 1 instance has its own diagnostic files. Node 2 has its own diagnostic files. So your SP file, control file, and few of the data files and the password file which are shared. And other than that, whatever your P file, data files, and the password file, redo log files, arclog, alert, which are non-shared. Each node has its own specific files. So this is one of your common confusing questions. Is all the data files are shared in RAC? Answer is no. So almost all the data files are shared except undo. Undo will be instance specific. Node 1 has its own undo data files and node 2 has its own undo data files. Another common confusing question in the interview is my redo logs are shared? No. My RAC node 1 has its own set of redo log. My RAC node 2 has its own set of redo logs. So if I can quickly connect to my lab, and if I go to one of the database on node 1, prod CDB1, on node 2, have prod CDB2. But if I do select all the data files, name from, or I can go with the SP file first, show parameter SP file. So I have this plus data, prod CDB, and parameter file and SP file. So if I do the same on the second node, plus data, prod CDB, parameter file, and SP file. So your SP file is a common for both rack instances. If I do create P file from SP file on node 1, and if I do the same thing on node 2, and if I come out of this cd $oracle home /dbs on node 1 ls-l, and if I do the same thing on the second node ls-l, so I got my init prod cdb2.ora, and we got this init prod cdb1.ora. So node 1 has its own P file, node 2 has its own P file. My P file is non-shared, whereas my SP file is shared. And coming to control file, go back to your database, connect to your database again, select name from $, control file. So I have this control files which are under data disk group and record disk group on node 1. If I run it on the second node, it will be shared one, plus data and plus echo, which are common to your rack instances. So that's why I mentioned here data files. Control files are shared one. And data files next. Select name from $, data file. So I have a multiple data files, VDB and CDB level. So system, sysocs, you have this undo tablespace 1, and you have this undo tablespace 2. You have two, tablespace 1 and tablespace 2. So undo tablespace 1 is for instance 1, undo tablespace 2 is for your instance 2. Other than that, your system, sysocs, and your temp all are same. So your data files, system, sysocs, temp, and users all are shared between your rack instances. but whereas your data file undo is a instance specific. Right, and then password file. Password file, you can keep the password file as a shared single file for both the instances, or you can have password file locally for both the instances. So advisable or best practice is to always have a shared common single password file. So you can use srvctl config database -d your prod cdb. So we have this password file plus data prod cdb password file, and this is your password file. So which will be shared right now for this database. And you can remove this shared password file and you can keep both local password file for both instances. That also works. And your redo logs, non-shared. Your instance one has its own redo log. Instance one has redo log 1 and 2. Instance 2 has redo log 3 and 4. Again, if I can connect back to database, describe WEEKDAYS log file, select your redo log group, comma your members from WEEKDAYS log file. Let's format that and rerun the query again. So your redo log group 1 and redo log group 2. So these two redo logs, group 1 and group 2 are belong to your RAC node 1 prod cdb1 instance, and redo log group 3 4 for your second node RAC second node prod cdb2 instance. So your redo logs are non-shared. Each instance has its own set of redo logs. And whatever this redo log is going to generate arclog, again that's the instance specific. Alert log or tag log are instance specific. So node 1 has its own set of alert log. If I can go to U01 app, Oracle diag, RDBMS, and prod CDB, instance 1 and trace. So this is my node 1 alert log and diag location. This is my node 2 where I need to change that instance name, same location. That will be my instance name, prod CDB2. Prod CDB is your database unique name and prod CDB instance 2, and prod CDB is unique name here, and it's a prod CDB instance 1. Under that trace, inside that I have this node 1 alert prod CDB instance 1.log, and on node 2 we have this alert prod CDB instance 2.log. So if I do ls-ltr here, I'll be having all the trm file, trace files, multiple things for instance 1. And if I go for node 2, the instance 2 specific, all the trm trace files. So all of them, those are called your diagnostic logs. Diagnostic logs includes your code dump files, trm files, and your trace files, and your incident files, and many more. These all are like your diagnostic. These are like your instance specific files. That concludes your database side understanding of the file system. And out of these files which are may be shared and which are may not be shared, and these files where they resides, the files maybe resides under your ASM file system or the ASM storage, and files resides under OS file system. So what we understood was files may be shared and non-shared for the RAC database instances. Now files which are under ASM and files which are under OS file system. So in OS file system, you have your P file, you have your password file, and we have your alert, whatever this alert log and diag log, all are under your OS file system. These are your OS side, not on the ASM storage. Your P file, password file, alert logs, and diag logs are all under OS file system. Other than that, whatever you see, everything under your ASM storage. Your SP file, your control files, your data files, your read logs, and your archive logs. And again, you can keep a password file in ASM. Right now we have in ASM. Once you copy it locally, that will be a local file. All of them are under your ASM storage. Apart from this, whatever diag log, alert log, password file, and P file will be local OS file system. So based upon your configuration current setting for any client, you have to identify where are these files and then take a necessary action. Almost all we prefer to keep it under ASM file system for RAC databases. If anything under outside of ASM file system, let's say you have local P file, so it's not advisable to run with a local P file. Remove that local files, whatever you have it. You have to have the SP file, which is in the ASM disk group. Your local password file, remove that. No need to have a local file system. It is supposed to be everything under ASM storage. Right, that is your simple understanding on the RAC database and the architecture part. Architecture part, it's remains same. Your instance and background process and memory, whatever the standalone database architecture we wish to understand, it's remains same. But it will be having multiple instances, multiple memory and background process for each RAC instance specific, and underlying data files are remain shared for all the instances. All right, I'll take a pause here for a minute if anyone has any questions.
Yeah, hi Malik, can you give me an intuition that why undo data file is not shared?
Your
It is
user
private.
specific. The user one is connected to instance one. He will be generating his own redo logs. He will be writing its own redo logs. That's instance specific. And whenever he do some modification, what is the use of undo? To keep that updated. Whenever there is update transaction, old image will be in your undo. So user one connected to instance one, he will be doing the transaction on instance one. All those transactions will be reported to that redo logs of that instance one. So whatever the block is going to change it, it will be kept under that particular undo data files for that instance one. Whatever user connected to instance two, he'll be doing all the transaction in instance two. All those transactions will go to that instance two specific redo logs. And whatever the modification or update you'll do, all those old image will go to that undo data files. Right? Your undo depend upon your redo or the transaction, the user who are connected to that. All right.
Okay. So for you have shown few files are non-shared and few files are shared. So how to understand? Let's say SP file. I think SP file is shared, right? So
You have to run
but
the
but
multiple command. I showed you all, like you have to run this srctl config database and see where is your password file, where is your SP file, or you can connect to database and do show parameter SP file. I don't want to tell you whether you're using a local file or shared file. All right.
Malik,
Yeah, good.
is archive in non-shared mode?
The archive logs are generated from redo logs. Right. So you can have redo log 1 and redo log 2 for instance 1, and those will generate its own archive log. And here redo log 3 and redo log 4 for instance 2, and those are going to generate your its own archive logs. Right? Those will be in your ASM storage, but those are instance specific. Meaning here shared versus non-shared. Is it instance specific or it's a general one? Let's say your system data file is only one data file. Both your instance one will be writing to one single data file, instance two will be writing to one single data file. But whereas redo logs, it's an instance specific. Instance one will write only its own redo log. Instance 2 will write only its own redo log. Instance 1 will generate its own arclog. Instance 2 will generate its own arclog. So instance 1 arclog cannot be generated by instance 2. Instance 2 arclog cannot be generated by instance 1. So it's an instance specific. That's the meaning of non-shared here.
Okay. Thank you.
But when it comes to recovery, let's say my instance 1 is crashed. My instance 2 is going to recover that instance 1 by reading the archive logs generated by instance 1. So that's a different concept. But here what I mean to shared and non-shared, is it an instance specific or is it a general common file? That's the understanding. All right. So with that, let's
Yeah,
talk
Malik,
about
Malik, yeah, I have a question. What about taking backups? So if we're taking backup of all the nodes, are we going to take a backup of just one node, or are we going to take the backup of all the nodes
the
differently,
backup.
separate?
Let's understand what you want to backup. What you want to backup? That's a question. So ideally, any backup you do, we backup first SP file, we backup control file, we backup all the data files. Data files includes your system, sysocks, user, temp, and undo. So ideally, when you do a backup using RMAN, RMAN will never backup your temp file, which are temporary purpose files, which you don't have any actual data. So you can exclude that. So if your local manual copy, then you are going to copy that temp file as well. System, sysocks, user, undo, all these files you're going to backup. So these are must backup. Your admin is going to backup SP file, control files, data files, and your point in time recovery you want to do, you can backup your archive logs. So again, there might be a questions in the interview. Is RMAN is going to copy that redo log files? No, RMAN will never copy that redo log files. And in case of your database crash happens, you may be having that much of a data loss situation. The whatever the content or whatever the transactions which is available in the redo log. And how to avoid that data loss situation? Let's say what I'm talking, let's forget about track. I'm talking about a standalone. Let's say you have a database and then you have redo log 1 and redo log 2. Let's say client 1 connected to my database. He had done that insert employee table and then employee ID 1. Let's say I have this employee table here, employee ID and employee name and salary. He did this employee ID 1, name A, salary 1000. And then these transactions, whatever returned from the redo log buffer cache, it will be returned to redo logs. This whatever the transaction. So in this case here, your database server crashed and your redo logs got deleted. Some reason, some OS corruption happened and your redo log got crashed. Then you will be having that data loss. That much of redo log, whatever written here, you'll not be able to recover it because your entire server crashed and storage crashed and you'll not be able to recover them. So because of this corruption, what we used to do, how to avoid this corruption, we used to copy this redo log as an archive log into separate location so that we can use that archive log and do a point in time restore and recovery. So we can do all the archive logs, whatever available to the point in time recovery, but whatever the content written on that one set of redo log, live transactions, that might be a data loss situation. So how to avoid this data loss situation? Oracle strongly recommend instead of using one single set of redo logs, go for multiplexing. Multiplexing of your redo log, meaning write redo log into multiple locations so that if you lose one redo log, you have other set of redo logs where you won't lose that data. You can able to recover that data, which are these current transactions and the redo logs using that other set of redo log files, multiplex redo log files. That's the advantages. Right, go back here. So your RMAN is going to copy or backup all these files. And one of the interview questions is RMAN is going to backup redo log files? No. Then how to handle that redo log loss situation by enabling that multiplex redo log files. So that one redo log files is corrupted or crashed or deleted, you have other set of redo log. So you can copy them and you can recover up to point in time or point of failure. So in order to backup, let's say I have instance 1, I have instance 2. All of them are referring to same database. Let's say in this prod CDB, in my case here, prod CDB is your database. So all these files, SP file is here, my control file is here, my data files are here on shared storage, and my archlogs are here in the shared storage. So if I connect to this instance 1 and run rman backup, everything will back up from the instance 1. Let's say my entire database, combination of this all together, it will be forming 1 terabyte. My data files, password file, SP file, control file, archlog, all together, size will be of 1 terabyte. So let's say I'm going to take the rman backup using channel 1 and channel 2. I'm going to allocate 2 channels by connecting to this server 1. Let's say here I'm talking about rman target slash. So I'm going to connect to this prod CDB from this node 2. I'll run this, I'll allocate this channel 1, channel 2. I'll take that entire 1 terabyte backup. Or I can go to node 1, rman target slash, connect it to your rman on this node 1. I'm going to take the backup using this channel 1, channel 2, parallel channels. Let's say I don't want to take with the parallel channel. Give me a second. Okay, logs. Let's say I don't want to take the single channel, I'll take it. I'll connect to node 1, the node server 1 or server 2. I'll go with only one channel. If you take 1 terabyte with one channel, let's say it will take 1 hour. Let's say same thing rman. I'll connect to node 1. I'll allocate the same single channel. I'll take the same backup, 1 terabyte. Again, that will going to take 1 hour. So you connect to any one of the node, either node 1 or node 2, allocate that single channel and take a backup. 1 terabyte will complete in 1 hour. Fair enough. So I want to increase that backup speed. So instead of one channel, I'm going to allocate to channel 2 from the node 1. So 1 terabyte backup will be completed in 30 minutes because you're using multiple channels here on this. And again, if you connect to second node and take that 1 terabyte backup, you can complete in 30 minutes because using 2 channels now. So whenever you run the rman backup from the node 1 or from the node 2, how many channels you're going to allocate? Your backup time will get reduced. So fair enough, but what happens here if you allocate multiple channels? You are going to consume more resource from this node 1. You're going to consume more resource from node 2 if you're allocating multiple channels. And in rman, we have a feature, backup using scan. Using your service, or you can just say scan. So what you're going to do, you're going to connect to this node 1. You're going to allocate channel 1 on this instance 1. You're going to start the channel 1 here. And even though you're connected to only this instance 1, you're going to allocate the second channel on your instance 2. So this channel is going to allocate here second. So remember, you're going to connect to only one server, like rman target, either node 1 or node 2. But there is a way you can allocate this channel. Allocate this channel 1 on instance 1, allocate this channel 2 on instance 2 by defining the service name or the scan name. Once you define the service name, your channel 1 will go under node 1, channel 2 will go under node 2. And you should be able to complete your backup within 30 minutes. But you're not going to put a load on these servers. You're going to put only the channel 1 load on the server 1, channel 2 load on the server 2. With a minimal load putting on the server, you can able to complete that backup with lesser time. So that is your advantages of services. You have something called database services, or you can use a scan to allocate the channel, to distribute those channels across your rack cluster node, so that you're going to be able to complete that backup in a lesser time, and also at the same time you're not going to put the load on the server. As if you're using only one channel, instead of completing in 1 hour, you're going to complete in 30 minutes because you're distributing the channels on your rack cluster node. But that's possible. Make sense? That's your distribution.
Malik, in one instance, we can have how many channels at max?
That depend upon your CPUs. If you have 10 CPUs on a server, you can use 60% of those 6 channels. You can use it on that server.
Okay. Okay.
If I do a node 1 ls CPU, so I have a 2 CPU on this server. I can max use 2 channels, but if I use the 2 channels, my entire database will crash, because when you're taking a backup, entire 2 channels, whatever available on the server, will be consumed. But how your database is going to operate, how your Linux server is going to operate. So always it's recommended, if you have 10 CPUs, and go for 60% to 80% of channels. 60% meaning 6 channels, 80% meaning 8 channels out of these 10 CPUs. You can allocate these 6 channels or 8 channels to your backup. And if you allocate 6 channels, remaining 4 channels kept for your database operation, kept for your OS operation. If you allocate 8 channels for your backups, remaining 2 channels out of these 10 will be kept for your database operation or your server operations. So the 60 to 80% channel you can allocate during only non-business hours. So if you allocate the 60 to 80% during the business hours, there will be heavy transactions on your database, and thousands or millions of users are connected, and all those transactions will be hanging, and there will be database performance issue. So we never allocate or we never trigger backup during the business hours, and we have to trigger this backup during the non-business hours by allocating the 60% to 80% CPUs.
Okay. And admin target, can we have it in different server?
That's a different story. So that's your repository database.
Okay.
All right. So that is your overall understanding of your database architecture in comparison with a standalone versus rack, and where those files are located, what are the services, and which are shared and non-shared, which are in ASM and which are in non-ASM. And with that, there'll be a couple of questions or couple of again, this is a purely, once you understand the fundamentals and once you understand the rack fundamentals, then you should be able to answer all of this. But for now, a few commonly asked interview questions in most of the scenarios or most of the interview. One is how you can install. Like again, I used to repeat these questions in my database sessions as well as my regular rack session. I'm gonna discuss this question again and again. But now the tool we are going to use it for installation of Oracle Home or Oracle software is the run installer. So that I told here, the rack installation here, right? Where is that? Right here. You're going to unzip that database software and you're going to run this run installer for Oracle Home installation. For the GI Home installation, we're going to unzip that 19C GI software. We're going to run this grid setup software. So this is one of the common, like if you're attending for some basic like a DBA role, around 3 to 4 years of experience, these are like your expected questions around that. And where this run install is available, under that Oracle Home, wherever you download and unzip that software, you're going to able to get this. And then on top of that, if you want to create any database, like I created here prod CDB. The tool used for creation of database, we're going to use this DBCA. which is available under Oracle Home and bin. So let's say if I go to this on node 1 or node 2, ls. So I have this run installer on node 1. So again, I'm not going to install when it comes to RAC, I'm not going to install this software on second node. It will be always on node 1. Automatically once you install on node 1, it will be copied to second node. And the tool used for database creation, RAC database or standalone, doesn't matter. I'll go to that node 1, Oracle software, and under that bin, DBCA. So I'll run the DBCA. They're going to ask me database name, location, and all. I'm going to create my database. And the tool we use for ASM home installation, that's a grid setup. I'll unzip that grid software on node 1. The moment I unzip, that grid software comes with this grid setup.sh. I'll run that and I'll give that all the IP addresses, VIPs, and CAN IPs. And I'm going to set up this 2 node rack cluster. Right, and then if I go further for my ASM, so I'll connect to my ASM plus ASM, SQL plus /s sys ASM. So I'm going to use this SQL plus /s sys ASM to connect to your ASM instance. Right, so how a DBA, how to connect to your ASM instance? How a DBA can connect to ASM instance? How you can able to connect your ASM instance by running this SQL plus as sys ASM. If I want to connect to my database instance, I have to set the database environment .env plus prod cdb1, and if you go this env grep ora, so it will be set to your database instance. Now I can use SQL plus /s sys DBA. So here I'm going to use sys ASM for my ASM instance connection. Here I'm going to use sys DBA for my database connection. That is your how DBA can connect to database instance or how to connect to that database. I can use SQL plus sys DBA. So once you connect to database, select name from VDalert data file. So I have this data, or if I do select name from VDalert control file, I have this plus data control 1 plus reco control 2, 2 control file. What are these plus data plus reco? These are your ASM storage. Remember that grid is made up of RAC cluster and RAC ASM storage. So this is the ASM storage provided by Oracle. So how to go to this location? If I try to CD into that, it's gonna say plus data is not a file or I don't have that location. So that's your ASM storage. You cannot use the OS command to go into that. That how a DBA can connect to ASM storage to do any admin activities. That we're going to use ASM CMD to connect to that and then to go inside that and to check all the whatever the files available. That's the next question. Question number 6. How DBA can connect to ASM storage? How to connect your ASM storage? Again, you can set the login to Oracle user, run the .env, set the environment to your plus ASM1 or plus ASM2. If you're connecting from node 1, it will be plus ASM1. If you are connecting from node 2, it will be plus ASM2. And verify your environmental variables are set to ASM, that plus ASM1 and your grid home. And then now you can use your ASM CMD-P. They're going to take you to your ASM command line. Now we can go to that any path here. If I go to CD into that ls-l, I can see that control file 1. If I can go to reco, CD into that, do ls-l, I can see the second control file. If I want to see all the data files, I can go into data, prod CDB and data files. Copy that path and CD into that. ls-l. I can see system, sysocs, undo 1, undo 2, and users. All will be available. That is your ASM storage. So ASM storage can be managed only this ASM command line. All right. That's about your how you can connect to ASM database and ASM storage and how you can install the ASM or cluster or
हालत नाही रे प्रायमरी
database
डेटाबेस शटडाऊन झाला
and the Oracle Home. Once that is done, then the things will get complicated. Meaning, will this is the basics what we do, but on top of that, we'll expose to multiple utilities. One is SRUCTL versus CRUCTL. So one of the common questions, how to or tool to manage your database or database services. We can use SRUCTL and tool to manage cluster. So we use CRUCTL. So we have this a CRUCTL and SRUCTL. So you can run thousands of connection commands using this. So if I do just SRUCTL dot .inv prod cdb1. So if I do just SRUCTL hyphen help, so there will be thousands of commands you can run it using this SRUCTL. So if I keep scrolling up, scrolling up, scrolling up, it will be keep pulling up. So I ran here, and these many commands I can explore on that using this SRUCTL config, export, status, stop, start. There will be thousands of commands. What we run it using this SRUCTL to manage my database, manage services, manage resources, the VIPs, scan, everything I can manage using this SRUCTL, almost all. And we have other tools, CRUCTL, to manage my cluster. If I run plus ASM1, CRUCTL hyphen help, so it's a very less activities with the CRUCTL. So I can run these many commands with the CRUCTL. CRUCTL stop cluster, start cluster, and bounce services and get the details. So many commands I can do it using a CRUCTL. So simple definition, manage my cluster. I can use CRUCTL, stands for cluster control utility. Manage my database or services or even your listener, anything, almost all everything in the RAC cluster, I use SRUCTL, server control utility. So if I see this SRUCTL help, there will be thousands of command it is supporting and I can use that. And for example, few example for my database prod CDB 1. Again, I will be always setting prod CDB 1 because I'm at node 1. If you're at node 2, you have to use prod CDB 2. So couple of commands, SRUCTL, status, database hyphen D, prod CDB. So I'll check my database status. Prod CDB instance 1, instance 2, running on node 1 and node 2. I want to check my prod database configuration. I'll use config. So it's going to give me entire my database configuration. Likewise, I can run hundreds of commands specific to my database. Let's say check my database and check my database configuration. And I can do stop my database. It will be complete stop. And I can do start my database. It will do entire rack cluster, node 1, node 2 instance, everything will down. But I don't want to do it. I want to do it only instance specific. Stop and start. I can do it. SRUCTL stop, instead of database, you can do stop instance -I prod cdb instance 1 and -D prod cdb. So you can stop your instance 1 or stop your instance 2, or you can start your instance 1 and start your instance 2, or even you can check your status for the instance specific. But again, this all comes into picture based upon how much you do hands-on. So this is, you're going to shut down that instance 1. This is, you're going to shut down that instance 2. So just a few examples for your SRCTL utility, how you can deal with your database. Likewise, you can do for services, listeners, and almost all. You can see
Yeah,
this.
Malik, I have a question. This SRVCTL, the command has to be issued from the like a command line at the OS level, right? At the OS level.
Right. That's correct.
Okay. Okay. Now, but rationally, we need to be connect to the database the same way we do like connect at 6 DBA. So that means anybody can just probably if I leave my system open like that, so that means anybody can just issue this command and shut down or start or stop my database.
Yeah,
You
that's
think,
correct.
yeah,
That's
for
correct.
real. Okay, but I think don't you think there's a security concern regarding that? Because now if the person has to connect to the database to start up the instance, they need to have the password to connect to the database to either start up or shut down the
You don't need
instance.
that. You don't need, like, and once you connect it to your server, so I can use SQL plus /s is DBA and I do shut immediate. I don't need a password for my database connection. I just use SQL plus /s is DBA. Right? Where is the database password? If you open your laptop and go away, and anyone can do shutdown using SQL command line, anyone can do shutdown using SRCTL. Doesn't matter. All right.
So, Mallikarjun, good morning. So, what all processes that we follow in case of restoration of cluster and database?
That's a different. So it's too early to jump on that.
Okay.
A different process, like, we have RMAN backup and restore, recover to do a database. And in case of cluster crash happened with what? We have a OLR, OCR, routing disk, which is corrupted. What is corrupted? Based on that, you have to restore that OLR, OCR, and routing disk.
Okay. In case of, say, decommissioned database, suppose 5 years back it was decommissioned and again client wants to restore everything as per the previous setup.
Decommissioned, you have to be brand new setup. If you decommissioned your cluster, then it's a brand new installation. You have to go and then install everything from scratch.
Okay. You mean that previous cluster restoration is not possible?
What is mean restoration?
Suppose 5 years back.
If you set up your RAC cluster, it has to be up and running. If you decommission your RAC cluster, it will be permanently decommissioned, removed forever. And then you want, after 5 years, you want to reinstall it, it has to be brand new installation. There's no backup and restore of cluster.
Yeah, suppose backup is taken and. Okay.
No, there's no backup concept of cluster.
Okay.
Cluster, either you set up and run forever or decommission and remove forever.
Okay. So only database can be restored.
Only backup and restore supported in database.
Okay. So cluster would be new and then the respective database can be restored.
Right. That's correct. Right. What is cluster? I told you cluster is just a combination of your servers. You can do a brand new setup and you cannot set up cluster now and then keep a copy of that cluster for restore purpose. No, nothing like that. All right. So with that, I'm gonna other command crctl.
Sorry, sir, interrupt you. Sir, can you use both the way to shut down database using SRVCTL and connecting to the SQL and shut immediate? Both
Right.
the way we can shut down the database.
Yes, you can do that.
Okay, thank you.
Right. Few commands on the cluster wide. crctl stop crs, crctl check crs, crctl start crs. Same thing you can do for HAS, HAS. Again, we have multiple cluster resource. crctl stat resource -t. You can do hyphen init. So they're going to give you all the cluster resources. So if I do crctl stat resource -t, you have a CSSD, CRSD, CTSSD. So you can go for each of them. So if I want to check my HAS, my Oracle High Availability Service is online. I want to check my CRS. So my Oracle High Availability Service, Oracle Cluster Ready Service, CSSD and CSSD, CRSD, CSSD and Event Manager, all are online. So you can have crctl check cluster hyphen all. So you can go for your entire cluster word crctl check cluster all. It won't tell you node 1, all the cluster resources are online, and node 2, all the cluster resources are online. Being on one single node, you can check your all other cluster resource. So instead of hyphen init, that's going to give you only the cluster resource. So you can remove that hyphen init, just do only crctl stat resource -t. That's going to give you all the cluster as well as your database and local resource. So they're going to give you more output. In a tabular -t is your tabular format here. Your listener running on node 1 and 2, your database listener running on node 1 and 2, your CHAD running on node 1 2, net 1 network. Again, all of these has its own task. We'll discuss more in our regular class. ONS, the notification service, and your ASM net listener, and your data, and data C, and your scan listener 1, scan listener 2, scan listener 3. So
Malik, you are not audible.
how about now?
Yeah. Yes, it's audible.
So again, these are the just two tools I introduced. So again, there'll be multiple tools, Cluffy and OLS nodes and OCR dump, OCR check, and then OCR config. So there'll be multiple tools at the cluster wide where you can use it for day-to-day operation to maintain your cluster check and status and health. So these are like your few example of cluster tools. Again, we'll explore more on our regular classes. What is this Cluffy check, OLS nodes? And just a simple example, OLS node will tell you what are the cluster nodes and what are the IP addresses associated to that -I. You can have this IP is assigned or tagged. You can explore more option on that. Again, simple to help and what are the options you can use it along with the list notes. Same thing goes for your OCR dump, OCR check, OCR config, Fluffy, and all of them. So these are like few example in the interview. Ask what are the, or give some example for cluster tools. Fluffy, OLS node, OCR check, OCR dump, SRCTL, CRCTL, all are your cluster tools. All right. So with that, I'm going to wrap it up for today. Any questions so far? Whatever we covered, or any questions around the course? No questions, nothing. If no questions, or any other questions or interview questions you came across recently, so we can spend few more minutes.
So Mallikarjun, so classes would be conducted next week from Monday.
Thursday, Friday.
2 days, Thursday,
Right.
Friday.
Yes.
Okay, same time.
Right. I'll share the details. I'll add you to WhatsApp group and I'll share the details after this session.
Means a new WhatsApp group would be created and then
Right.
would be following accordingly.
Right. That's correct.
And these 2 days recording would be there, na?
Yeah. It will be there.
So we will get it today or
Yes.
today?
Yeah. I'll share it. I'll share more details after this class.
Okay.
All right. So if no questions, let's wrap it up for today. We'll continue in our regular class.
So Mallikarjun, if any clarity needed, then we can put our questions and messages in the group.
Yes, that's correct. Only the WhatsApp group is primary communication. Any questions, queries, any doubts, or any help, or stuck with any setup, just post it in our group.
Okay. And drive access would be provided next week.
By today or tomorrow.
Okay. And during other days, can we expect help or
They can post anytime.
Okay.
The group will be there for primary communication. You can post any questions, not only for 2 days, like any day. So like if I'm available, I'm free, immediately jump on a call, or I can reply back at least to your questions. Or anyone already has that, or they'll reply back or connect with you and they can help each other and then
Okay.
you can
Okay.
clarify.
So
all the
within
questions.
team, all people will be available to others.
Already there are a previous batch students also there and some senior folks also there in the group. So anyone can help.
Okay.
Okay, yeah. Malik, is there going to be like a difference between the previous group, like the standalone 19C we did, and this RAC group, or is still one group?
No, different groups.
Okay.
All right.
And can you give us the video when you joining the class?
Yes, all again, you attended yesterday's sessions or no?
No, sir.
Yeah, we'll be you will be getting a recordings of previous batch recordings, and also you'll be getting this current live batch recordings. And you can watch the previous batch recording before attending these live classes so that you can interact more and ask more questions. And also everyday sessions will be recorded and uploaded into Google Drive. Even you will get those recordings. And again, if you're unable to join, you can watch those recordings. That's also there.
Okay, thank you, sir.
All right. Let's wrap it up for today. We'll continue by next week onwards with our regular classes. I'll share more details in our group and I'll add all the registered student into group. And stay tuned. We'll be getting all the access and more details in our WhatsApp group. All right, guys. Let's
Okay.
take a break
Thank
and
you.
have a great
Thank you so
weekend.
much.
Bye.
Bye, Malik.